Hello everyone and welcome to Introduction to Unity. In today's episode we will dive deep into the transform component of a game object. Let's go! What is a transform? As you can see in the right side of the inspector, every game object has this transform component. And even if you create a new object, it will always come with a transform. And this is something that is critical and imperative for the game object. And if you want to know more about the game object, I already have a video. You'll see it in the description below or on a pop-up on the side of the video. A container that stores the position, rotation, scale, and parenting state of the game object. And it's represented in here, as you can see in the inspector of the Unity window. And you will notice that the position, rotation, scale, they have three values. They've got the X, Y, and Z. It's because Unity is a 3D engine, and to represent stuff in a 3D dimensional way, you need three values. And to simply put it, if we have our player in here, you will see that it already has a preset position, rotation, and scale. And the X means the horizontal axis, which is the red thing in here, which goes left to right, while Y is the vertical axis, which is representing the up and down, which is the green here. And these two by themselves, they represent the 2D space, while if we add the third one, which is the depth, and it's called Z, it represents the front and back. And with those three elements, we combine into something called vector 3. And you will notice that vector 3 is going to be used throughout your whole game development, because it's used in positioning, rotation, scale, color, and other bits in the game. We want to go and see how does it change, how can we manipulate it, and what does it do inside the scene view. Having the player selected here, we can literally change the position, rotation, and the scale, either in the inspector or inside the scene view. So what I will do is I will do both actions at the same time to see how it affects, but the results will be the same. For example, if I go ahead and say I want to change the x-axis value to -1, it will move into the -1 direction, which is the left side of the player. While if I put it 5, you'll see it's gone, because it went to the right side away from our view. Having this set back to 0 brings it here. You can also manipulate it by holding the left mouse button on the X and moving left and right. So having this incremental value will go into the positive direction, and the negative will go into the other direction. And what does represent the positive and the negative? As you can see here, whenever we select any game object, you'll have these three axes pointing to each direction. As we said, the x-axis represents horizontal, and it is the red axis. So any positive value will go ahead into the side of the arrow, while going against the arrow will reduce it, as you can see in here. It's going up and down. Similarly happens to the y-axis, which is the up and down, the green one in here. So if I go ahead and increase it, you'll notice the y value will change in here incrementally, while if I go down, it will decrease the value. The same bit will happen to the z-axis, which is the blue one in here. Having that said, we have an extra bit of manipulation that we can do. Let's say if I want to move the object in both axes at the same time, instead of having to do like left and then forward, what we can do is we'll see there's a dot between, like a dot connection between two axes, and there's a small cube in here. If I hold this cube and move it, it will move according to these two axes. And at this stage, it's moving according to the x-axis and the z-axis. It has the same thing in the x and y, and then between y and z. We move next to the rotation. So the rotation also is represented by vector 3. And how do we change it is by either clicking this button in the toolbar, which is the rotation tool, or clicking E. So this will change the gizmo icon here. As you can see, it was set up to 3 axis. Now it has some sort of like a rotation bit, spherical thing, and it still has the same coloring. So the coloring, as you can see, is the blue represents the z-axis, the back and forth, while the y represents the vertical, which is up and down, and the red represents the horizontal, the left and right. So if you want to rotate according to the left and right axis, it will bend back and forth, while the green will change it according to the y, left and right, and the green and the blue will go ahead and change it left, like sideways. So we can manually change it in here and then see the values represent in the inspector. Similarly, we can do it in here, or just typing the value like 90, and that's how we modify the rotation. Similarly, we can go next into the scale, and this will enable us to have a new gizmo similar to the positioning, but with cubes instead of arrows, and these will have the same effect in terms of scaling depending on which axis we choose. If we go in the sideways or up and down, whilst if we click inside on the gray one, it will unanimously increase and decrease the scale. As you can see, the values is getting changed inside the inspector itself. So these are the ways of us making changes to the transform component inside the scene. Now we want to see what does affect this manipulation, and we've got two tools. The first one is the anchor, and the second one is the space, either local or global. So going to the first one, which is the anchoring, by default every game object has the pivot anchor, which means this dot is represented in the place that the 3D model creator has done in their 3D model software. And for this character, it's set at the bottom of the feet because it's the best way to handle characters itself. We can see that now we're applying changes according to that point. If I go and rotate, it will rotate around that point and scale according to that point. But if I go ahead and change it to center, what this does is it will choose automatically the center point of the game object, or I would say the transform. And in this case, it's the belly point. So in terms of positioning, you will see it does the same thing, while rotation, it will rotate according to that point, and scale will do it similarly as well. The next one is the space. We've got the local and the global space. And to have this explained better is every transform has its own local transfer parameters. Similarly, it has the global transfer parameters, and the local parameters represents itself, while the global, it represents the parent or the whole scene parameters. So if we go ahead and discuss the local, which is already selected, is what we've been doing recently is by changing the position, rotation, and the scale according to itself. And if I go ahead and choose global, you will notice that this arrow has slightly changed. If you can see that in the local, it's pointing directly in front of the player, while global, it's pointing slightly away from the player. And that's because you will see on the top right side, there's a global compass, I would say, for the 3D scene. It's an orientation tool that can represent the actual global direction of the Z, X, and Y axis. And if I keep rotating, you'll see it still directs to the same place. And this is how the global setting will direct this anchor towards. So if I go ahead and rotate the object and go back to the positioning, this direction will remain as is, and when I change it according to the direction. While if I go back to the local, you'll notice that it's pointing according to the local of the game object itself, which can be useful in a lot of things like projectiles, moving things, or having things translate in the position according to their relative anchoring. So that's all about the editor inspector things about the transform. Now we'll have to move to the scripting. The first thing we want to explore in the script of Transform is the positioning. And as I said before, there are two spaces for the position, scale, and rotation, which is the local positioning and the world positioning. And before testing it, let's go access the script and see what is it and how does it work. So I've got a reference to a transform, and I've got two ways of interactions, which is clicking number 1 and number 2. So when we click number 1, all we do is we just log in the local position of the transform, while if we're pressing number 2, we log out the global or the world position. And simply you can access it by writing in the transform, then clicking dot local position. And similarly for the world space, you just go dot and position. Now let's go and see how it works in the scene. As you can see, we've got the script set up here, and it's referencing the player game object. And if we go ahead and click play, it's supposed to give us the local position when we click 1 and the world space position if we click number 2. So going back to the transform, we can see that the positioning currently is 0.5 and 0. And this position is considered the local position. So if we go ahead and click 1, it will give us exactly our position. So if I go ahead and change it like this, click 1, it will give me my position again. So that is good. And if I click 2, it will give me the same position that I have right now. So you'll be wondering, what is the difference between world and local? So the difference is this game object will always have its own local positioning, but it will also have a global positioning, and the global positioning is according to its parent. So at the moment, our player has no parents, and what does that mean is, if you open this one, you'll see that a game object can have its own children here. So you can see there's a nesting way in here when we can have a lot of children, but the player itself is setting in the root level. So to test this out, we've got ourselves a game object called test parent, and all we need to do is drag the player and put it inside that one. So by the look at it, when you click 1 or 2, you will still see the same results because I haven't moved it or changed it. The parent has the position of 0, 0, 0, which is fine, while the player still has 0.5 and 0. So if I go ahead and move our parent slightly upwards, you'll see that the player went up, right? But if you click on the player, we still have the same position that it had before, and this is because we have not changed the player itself, we have changed the parent, and its local position remained the same, but technically we've changed the world space positioning. So if I click 1, we'll still get the same results, but if I click 2, we'll get a different result. It's the combination of where the player at the moment is located according to its parent. So that gives us a perspective on what is the local and the world space positioning. And if you hover over the position, you will see that the local position of this game object is relative to the parent. So if you have a parent that has offset in X and Y and Z, this player will have its values according to that X, Y, and Z. So yeah, that's all about the position. We'll move to the next one. The next point is the rotation. And it's quite similar to the positioning because it does have local and global, but the rotation in Unity, it uses something called Quaternion, which is the representation of a 3-dimensional rotation object. I'll have a link in the description so we can read more about it. But the important bit here is we've got a script linked to the player, and it will show us what is called local rotation and the world rotation. So let's go in the script and see what is that. As you can see, we've got a transform reference, and when we click 1 and 2, so when we click 1, we will fetch the local rotation of the game object, or at least the transform, as well as the local Euler angles. So Euler angles is basically the X, Y, and Z representation in the screen, while the local rotation, as I said, is the 3D dimensional rotations values. we will display the local Euler, and at the bottom one, when we click to, we will display the same things but in the global space or world space. Let's see how it works. Going back to the scene, and we play it. Then we select our player, and then you will see that our rotations are set to these ones. So these three elements, they represent the Euler. So if I click one, it will display to us the Quaternion values, which is a 4 value thing. As I said, I've put a link in the description so you can read more about the Quaternion. While the local Euler, it gives us exactly our value. You would see probably slight difference in here. It's because when we get the value, it rounds it up to the closest value. So if I go ahead and rotate the player a bit more, and then into the X value a bit more, and click 1, we will get the exact values that we had. So that's good. Now if I go ahead and reset the position as it was and click number 2, you will see exactly the same values. It's because this game object is not really linked to a parent. So if we go ahead and put it in a parent in here and change if we click on the parent and change its rotation, you would see that if I click 1, we still have the player local, but if we click 2, it will give us its world space rotation, which is going to be helpful in a lot of things looking forward in physics or even transformation. So that's all about the rotation in terms of scripts. Now let's go to the next point. The next bit is the scale. Similar to what we had in positioning and rotation, the scale has also two values, which is the local scale and the Lucy scale. And it's called Lucy scale, but it does represent the world scale of it. So let's go into the script and see what is it. We'll see here that we have a reference to the transform, and then when we click 1, we're going to print out the local scale, and 2 will print out the Lucy scale. And it does say here that it has the global scale of the object itself. Let's see how it works. Clicking play, and we see that we have a reference of the player, and if we click on the player, we will see that our current scale is set to 111. So if I click 1, it will give me 111 because that's the local scale. Similarly, the global scale is 111 because this object doesn't have a parent. So if we go ahead and change the scale slightly in here, and you can also change it if you go back to the scene and then select the scale tool and go ahead and change the stuff as you want in here. Going back to the play mode, if I click 1, I get the values exactly as I have them here. So let's revert this back to 1 and 1, and let's make this player a child of another game object. And if we go ahead and increase the scale of that game object, you see that it's becoming bigger, but clicking on the player and clicking 1, it will still revert us as 111 because that's the player's scale according to its parent. While if I click 2, it will give you 222 because the parent has that scale. Similarly, if I change it, click 2, it will give me that scale of the parent. And I don't mean exactly the parent, I mean relative to the parent, because the game object have its scale relative to the parent. So let's revert stuff back, and that's it about the scale. And now let's see the next point. The next point is directions, and this could be useful when we want to get the forward, left, the right, the up and down position of certain bits in our game. And in here, as you can see, that similar to what we had before, the X, Y, and Z, I've just made an illustrative game objects in here to demonstrate where's the front and back, right and left, up and down. We have our own script here called Transform Direction, and what it does, it represents us the vector 3 values of all the axes given, back and forth, left and right, up and down. So let's see how this all works. Inside the script, you will see that if we click 1, what we do is we access something called forward in the transform, and what that does, it just gives us the 1 unit forward value of the transform, and since forward is z, it will give us the exact position plus 1, which is going to be 1. While if we want to get the backwards, all we have to do is put the same value in here and give it a minus in the back. And when we click 2, it will give us the right position, which is plus 1 in the x-axis. And alternatively, we can have this set to minus to give us the left. And last is when we click 3, it will give us the upper direction, which is plus 1 in the y-axis. And having this as minus will give us minus 1, which is down. It's because there are only forward, right, and up, and there are no left, down, and back. So that's how we use it in the script. Let's see how it works. Since at the moment our object is set to 0, 0, 0, if I click 1, it will give us the forward and backward vector, which is 0, 0, 1. That's correct because the z is 1, and it's exactly the same as this game object in here. And the backward is minus 1, which represents this game object in here. If I click 2, it will give us the right and the left, which has a plus 1 in the x and a minus 1 in the x, exactly as this game object, plus 1, and left is minus 1. And the last bit is clicking 3, which gives us the up and down, which is a plus 1 in the y and minus 1 in the y, similarly to how it shows in here, plus and minus 1. So this is just a small visual representation of the axes. And now let's go to the next point. In this example, we will talk about the parenting. And parenting is really important going forward with your games. You will see that it's going to have a huge impact on how you deal with objects and transforms. And in example, we've got 3 game objects. P1 is the left one, it's here, and P2 is the middle one, P3 is the last one. Going back to the game view, you'll see that the P1 doesn't have any children, while P2 has 1 child game object, it's called C1, and P3 has 3 game object children. In this example, we will look at how can we get the parent's name, and how can we get the count of the children and the name of each child of that game object. Let's see in the script. In here, we'll see that we'll have a reference to something called child transform and another one called parent transform. And if we click 1, what it's going to do is it's going to go into the child transform and get its parent and print out the name of the parent. When we click number 2, it's going to go ahead and go to the parent transform and print out its children count. While if we click 3, it will go also to the parent transform and loop through its children and print out the name of that child. And you can see here that the transform itself is used in the for each loop, which looks as it's a list or something, but yes, the transform is implementing what's called IEnumerable, which we can enumerate through its children. So let's go into the scene, see how it works. Let's click play. First of all, we need to have a reference to a child transform. So if we go ahead and select the C1, because it's the child of P2, and if we click 1, you will say C1 parent.name is P2, which is correct. So if you go ahead and select D2 and click 1, it will say D2.parent name equals P3, which is exactly correct. While if you select a game object or transform that doesn't have a parent, you will get a null reference exception. Why that? Null reference in general means you're trying to access or manipulate something that doesn't really exist, or it's null. And why is it null? It's because what the script does, it goes into the transform and goes one step up to the parent and gets its name. But since this game object doesn't have a parent, we're trying to access a parent that doesn't exist, in turn means it's null. So whenever you see this bit here, just go ahead and click on the line here, and then you'll find the why or the where it happens, and you can figure out why it happens. And the reason here is because this bit here, the parent is null. Let's go back. The next example is getting child count. So if we go ahead and reference P2, let's clear this one here. If I click number 2, it will give me P2 the child count equals 1, which is correct. If I choose P1 and click 2, it will give me the count of 0. That's proper because this P1 doesn't have any children. Having that said, going to P3 and clicking 2, it will give us number 3 because it has 1, 2, 3 children, and it represents here in the hierarchy. The last example is we need to print out the names of all the children in the transform. So if you go ahead and put P2 here and click number 3, it will just go ahead and say P2 child transform name equals C1. That's correct. Assuming that if I go on P3, it has to give me 3 values. And let's see, that's exactly what it did. It gives me 3 values, which is D1, D2, and D3. And if I go ahead and link anything else that doesn't have children, nothing will show because there's no objects as children, so there will be no results. So this is all about the parenting. Let's go to the next point. So far we've interacted with the most usable things inside the Gameobjects transform, which is position, rotation, scale, direction, parenting, and there are other bits that we can explore, which is going to be listed in this link, which I'll put in the description below. And it's got several bits, and we'll go through these bits with a minimal description here just to have more clearance. But again, feel free to go to the link and explore it manually and testing it in your own machine. We will start with the properties. So properties are basically values that we can access or change. So starting with the child count, we've noticed this in the parenting where we can get the count of the children of that game object. Euler angle is the X, Y, and Z of the rotation. Forward, right, up, these are the bits that we've discussed in the direction. And then you got has changed. It basically just gives you a flag on whether this game object has changed or the transform has changed recently. And having these 2 points here, hierarchy, capacity, and count, are something that can relate to the way of this transform is being represented in the hierarchy. You can go ahead and explore it and see how it affects. Local Euler is the same as Euler here, but this will represent the local values, while this one will represent the world space. Next points are going to be the local position, local rotation, local scale, and similarly Lucy scale, rotation, and position. So this one they represent what we discussed earlier of the main transform component. Local to world matrix, it's basically a way to transform the point from local to space. Parent is just the parent transform. If it has a parent, it will give you a transform object. If not, it was going to give you a null. And the last one is world to local matrix. It's the opposite of local to world matrix, which gives you in here it gives you the transformation from the world space to local space. And as you can see, these values are only read, they cannot be modified at all. Next, we've got the public methods, and methods are different than properties because properties is something that you can access and modify, while methods are something that you call and can give some input to it if required. Starting with, we've got detached children. So when you access the transform and go ahead and call detached children, it will automatically detach the children of that game object. Find, it will search for a specific child that you look inside its transform. Get child, it will give you a child transform of that game object. Get local position and rotation and get position and rotation are methods that can give you back the rotation and the position of the transform both locally and world space. Get sibling index, it gives you that transform's index. If you have a game object that has 10 children and let's say you want the index of, let's say, the specific child, and so what it does, it's going to give you the index of that child, and the index of the child is represented on what is the actual number of that child. For example, you can have 4 children, so they will have from up and down 0, 1, 2, and 3. Inverse transform direction and inverse transform point, as well as inverse transform vector. So these methods, what they do is they transform the world to local space for direction, point, and vector. Similarly, there are transform direction, point, and vector, which does the opposite way, which transforms it from local into world space. Is child of is a method that gives you back Boolean if this transform is a child of a specific parent. Look at is a quick way of making that transform look directly at another transform. Rotate and rotate around are helper methods that can allow you to rotate that transform. And rotate, it takes in a vector 3, while rotate around, it takes in a vector 3 and an axis, plus it takes in the how do you want it to rotate. Do you want to rotate it in a world space or in a local space? So you might want to rotate something around a specific axis, or you just want to rotate them giving a specific vector 3 value. Set as first sibling and set as last sibling are things that relates to the children. So let's say I want that child to be set to the first or the last. That's why I call these methods. Similar to get local position rotation and get position and rotation, we've got set local position and rotation and set position and rotation. So that one, it just gives you the values, and these two just you can set the values to that transform. Set parent is when we want to set a parent to this given transform. Set sibling index, it's similar to the set as first sibling and last sibling, but what this does is you can customize the way how you will set it. If you have 4 children and you want to change the first one to put it second, you just go ahead and put it set sibling index as 1, and it will automatically set it as 1. The last one is translate, and what translate does, it gives you the ability to move the game object, similar to what we have in rotate, which affects the rotation. Translate, it will affect the position of the transform. Well, that's everything that we can talk about the transform in a simple form, and there are a lot of things you can dive into it. As I said, in the link in the description you can access the script manual, and in there you can try and test all the methods and see what they do. That's all for today, and I hope you enjoyed it and learned something. Hit the like and subscribe, and I'll see you all in the next one. Bye bye.